Hello and welcome to Looking for Pythagoras 3.1. Our learning target today is I will use my knowledge about areas of squares and side lengths to discover the Pythagorean theorem. So that's what this book has been all about. We went through the first two investigations, kind of getting some background, and today we actually kind of get to start putting it into place. And in 3.2, we completely put it into place. Want to talk a little bit about some terms, vocabulary here for investigation 3. An acute triangle. An acute triangle is triangle A down here. Acute triangles, all three of their angles are less than 90 degrees, so that's an acute triangle. Secondly, obtuse triangle, that's triangle B down here. That means one of its angles, this one here, is more than 90 degrees. That makes it an obtuse triangle. And then a right triangle is triangle C down here, where it has a right angle or a 90-degree angle for one of its angles. Also on right triangles, they have what's called a hypotenuse. Hypotenuse is the longest side of a right triangle, and it is always opposite the actual right angle. So that's a hypotenuse. Leg, that's the other two sides of a right triangle. So this is a leg and this is a leg. I also have both of those illustrated up here. And finally, our last term to think about for this investigation is theorem. And in math, a theorem is a theoretical proposition or statement or even a formula that is embodying something to be proved, but from other propositions or formulas. So you'll see that'll hopefully become more clear as we work through this theorem. So in 3.1, what I want you to do is we have this these figures laid out here, and I want you to use the table from part A, and that's this table here. Okay, I want you to use that table and to record the area and side length of each square. So if we look at number 1 here, this A here is our area is 1, 2, 3 by 1, 2, 3. Okay, so our area there is going to be 9, and we'd fill that in right here as the area of square on side A. So that's going to be 9. And then our side lengths, as we counted, is 1, 2, 3. So we would count out our side lengths on that, and we'd record them here as 3. We do the same thing for side B, and then side C, as hopefully we've been doing throughout this process, is we're going to need to make a square around our diagonal square. So I'm doing this a little messy just to be quick. Whoops, went too far. Just to be quick, which I'm not being right now. Anyway, we want to put that square around here. Remember then, we find the area of the big square and then subtract out the triangles. So all this triangle area, we need to subtract that out. That'll give us the area within the diagonal square. And then if we take the square root of that, that will give us our side length of side C. So I want you to do that for all three of the triangles. See, we have numbers 1, 3, and 5 circled here. This is number 1, this is number 3, and this is number 5 to help you get used to acute and obtuse definitions. Now, after you have this table completely filled out for 1, 3, and 5, what I want you to do is then consider the Pythagorean theorem, which states a squared, meaning side A, okay, side A, the length of side A squared, plus the length of side B squared equals the length of side C squared. Now, once you do that, well, let me show you in the table. Okay, you're going to take this number, whatever's in this column, plus the number that's in this column, and see if it equals the number that's in this column. Okay, so that's going to be how we add up our columns, our side lengths for our Pythagorean theorem. Then, I want you to try to determine, is this theorem true for all triangles or just certain types, and explain how you know. Part B basically says the same thing. For each triangle, look for a relationship among the areas of the three squares on the sides. Make a conjecture about the areas of the squares drawn on the sides of a triangle and the type of triangle. Once you finish that up, then I want you to work on ACEs beginning on page 49, 1, 2, 4, and 17, A through D. Good luck. Have fun.